MPLS traffic engineering fast reroute or FRR with the feature we call it SRLG. In this video, I'm going to talk about the SRLG feature of the multiple backup tunnel about the fast rerouting in MPLS traffic engineering. First, we need to learn about the SRLG concept, SRLG usage, and after that we can talk about the SRLG configuration, also verification. Okay, the first thing that we should know is that SRLG is the abbreviation of the shared risk link group, or in some resources maybe you see shared resource link group, but the shared risk link group is the better words for the function of the SRLG, shared risk link group. First, we should know about the usage and functions of the SRLG. Let me to talk about that. Look at here. In this scenario, we have a tunnel 0 from the router 4 and router 5. We need to protect this tunnel 0 with a type of tunnel, for example, next hop or next hop backup tunnel. Assume that we are configuring the next hop tunnel from the R1 to R2 to R3. Let me to write here. Look at here. This is the configuration. We will talk about the configuration of this scenario in the next step. Let me to write here. Here, as you can see, first we need to draw the tunnel from the R1 to the R4 to the R5. This is the main tunnel, or this is the protected tunnel, R4 to R1. Okay, after that we have the router 6, after that we have the router 3, and finally the router 5. This is the path of our tunnel starting from this point, tunnel 0, to the tunnel 5. Okay, and we need to protect this tunnel. Assume that we are configuring a backup tunnel from the router 2. Look at here, I am configuring the backup tunnel from R1. Okay, you know that here we have R1 connected to the for example router 2. Okay, this is R1, this is the router 2, and also the router 2 connected to the for example router 3. Okay, here we are configuring one backup tunnel from the R1 to R3. This backup tunnel is the next hop tunnel. Okay, from R1 to R3, and the number of this tunnel is, for example, 10, tunnel 10. You learn about the configuration and also concept of the backup tunnels. Because of that, now you can easily understand the concept. Because of that, now we have one tunnel 0. This is the protected tunnel, and also this is the backup tunnel that we configured. Okay, and maybe in some cases it's so useful about the configuration of this tunnel 10 with same function. Also, we have another path, for example, from router 7. I will talk about that. Here we have one consideration. Assume that the path, the physical path of the, for example, R1, R2, and R3, okay, now is passing from the same physical, for example, conduit, or from the same physical link. This means that assume that we use a conduit, or we use for example physical pass. Okay, and both of these lines, both of these fiber, for example, are passing from a same physical pass, for example same conduit. Okay, in this time when the R6 fail, okay, or when the links of the R6 fails, in most cases the R2's link also fail, because both of them are passing from the same physical pass. Okay, because of that, if you configure the tunnel 10 as a backup tunnel, and maybe you wish that when the for example router 6 failed from or when the links of the router 6 failed, you can use the tunnel 10. Actually, in the real time, in the real scenarios, when this link failed or this router failed about the physical problems, also the router 2 and the link and the path of the router 2 will fail, and because of that the tunnel 10 will not available and you cannot use it. This is the consideration that we have. Okay, we can use SRLG feature, okay, when a backup tunnel can potentially be routed across a link that is on the same fiber or conduit as the protected link. Okay, If you configure the protected link and all other links that share the same fiber or conduit with the same SRLG identifier, the backup tunnel avoid those links. Let me to show you. Here, assume that we have these two links from the same fiber or from the same conduit. Okay, we can use a number. We can configure a number. We call it SRLG, or shared risk link group, in the interface of R1 for these two paths. SRLG, for example, 1, any value, but we need to configure the same value on this also interface. When we are configuring the same value, same SRLG in these two links, this means that R1 as a PLR should consider this SRLG, because we are saying to R1, this path's shared risk link group is 1, and also this path's shared risk link group is 1. This means that both of them have the same share, okay, same risk, okay, and you need to consider it when you are, for example, selecting the best path for the tunnel. Okay, for example, if we have another path from the R1, okay, assume that here we have another path from the router 1 to router 7 and then to router 3. Okay, this is the R1 to router 7 and then to the router 3, and we know that these paths are for example passing from this different physical paths. Because of that, we can configure SRLG of 2 for this path. This means that here we have different shared risk link group, and this means that it's better to using this path. And we can say when the path of the router 6 fail, this path does not fail or will not fail. Okay, why? Because it has different SRLG. Okay, we can use the SRLG as one of the constraints of the links when we have this consideration that when one of the paths fail, another path also will fail. Because of that, we don't want to use that path for the backup tunnel. Okay, we can use this feature for this condition. Okay, let me to review the SRLG feature. Look at here. We are using SRLG, or shared risk link group, by backup tunnels. We can use the SRLG when a backup tunnel can potentially be routed across a link that is on the same fiber or conduit as the protected link. If we configure the protected link and all other links that share the same fiber or conduit with the same SRLG identifier, the backup tunnel avoid those links. Okay, I will talk about the configuration in detail, but until now we can understand that this is the new constraints about the link, and we can manually configure this feature. Let me first configuring this scenario step by step. We can learn better about the SRLG feature. This is our scenario. Let me to show you the configuration. In some cases we need to for example modify the configuration, but about the most functions, most configuration, we don't have any change. Look at here in R1 about the first configuration, and we don't have any change. About the fast Ethernet 00, as you can see, the interface, the IP address is 10.122, and I configured the cost of 2 because I'm going to send the traffic of tunnel 0 from the R6. And then the fast Ethernet 10's IP address is 10.161, such as the previous scenario. And the interface fast Ethernet 20, this interface's IP address is 10.141, it's okay. Also, we have interface fast Ethernet 30, where the IP address of this interface is 10.131. And after that, we have interface loopback 0, OSPF configured. Let me to remove the configuration of the tunnel and also the explicit path, because I will configure them in this scenario. Here we have the router 2. In router 2, we don't have any change. Only in router 2, in this scenario, we have two interfaces, fast Ethernet 00 and fast Ethernet 10. We don't need the fast Ethernet 20. Let me to remove the fast Ethernet 20. The IP addressing is correct. The fast Ethernet 00's IP address is 10.122/24, and the fast Ethernet 10's IP address is 10.232/24. That's it. About the router tree, this is the router tree. We have 4 interface. Fast Ethernet 00's IP address is 10.233/24. It's okay. Fast Ethernet 10's IP address is 10.363/24. It's okay. Fast Ethernet 20's IP address